But the thing I would suggest is definitely, if you know that there's a thing you want to do, so say you want to be a mechanical engineer at an aerospace company, go out and seek out a person that currently does that job today, because they could basically be a mentor for you as you proceed in your career. Because I look back at myself in my career, and I don't know if I could have been successful at it had I not seen somebody that was doing what I want to do, to know that it's possible, right? Because you kind of hear that, yeah, everything's possible if you apply yourself. But sometimes if you can't visualize sort of what you want, it's hard to get there. So the things I would say definitely is, hopefully by the time you became a senior, you went and did internships throughout the years, because those really help, because you can get your foot in the door in various companies. Or you basically, whether it's LinkedIn or other networking means, make sure and network with people that are out in the industry, so that you have an advantage over your peer that's graduating at the same time and you have an in. Believe it or not, in my whole career, I've never gotten a job in my whole life where I've actually looked up, for those of you that you probably old enough to know what want ads are, but looked online and actually see, okay, there's a job posting. I've never applied for any job cold. Every job I've ever gotten in my whole life has been because of me knowing somebody and sort of getting and networking and getting in that way, which I find, I was very fortunate to be able to do that. So.
Yeah, no, I think networking is something that definitely can be of value, particularly right now, when a lot of these aspiring young aviation professionals and aerospace professionals are looking for opportunities and that type of thing. So I'm going to use that as a segue and take it to you, Shante. And you've also had an interesting path in terms of how your career started. And as you told me in our pre-show, aerospace wasn't even on your radar.
Yeah, yes. Actually, I grew up surrounded by airplanes. My mom has been at Lockheed Martin for going on 47 years. And so I just saw skunk works around the house all the time. I was probably the only 10-year-old that had a picture of Kelly Johnson on her wall. So I just loved everything Blackbird and U-2. Those were my planes. I was going to be a pilot. It was decided. And my mom, one day, she's like, "You're my only child. I'm not sure I want you to be a pilot." So I said, "But I'll be a good pilot. We have nothing to worry about." She's like, "Maybe not." She's like, "Well, why don't you design the planes? You could be the person that designs the plane. You can still be out on the flight line and see them operate and all that, but you don't fly them." I thought that was a reasonable compromise. And so I decided I wanted to be an aeronautical design engineer. Then my mom said, "Why don't you consider mechanical engineering? Because it's broader. It gives you more options. You can do aeronautical design engineering as a mechanical engineer, but you can also do other things." Because, I grew up with a family that was a working family, and they're saying, "You know what, you need to always be able to find a job. And so if aeronautics isn't working, you need to be able to do something else. So consider mechanical engineering." And so I thought, that makes sense. I was 10 years old. It made sense, So I decided.
So I'm sorry, you were having these discussions with mom at 10?
Yes.
About your career?
Yes, because you're going to get a job and you're going to move out. So let's get that established early. And so I ended up going on a tour of JPL, and I just fell in love with it. And I said, "You know what? I'm going to be a mechanical engineer. I'm going to work at JPL, and that's just."
How old were you when you went on the tour at JPL?
I was still 10. 10 was a very powerful age for me. Big year.
Yeah. But that opened your eyes, huh?
Absolutely. And I just looked at all the things that mechanical engineers could do. And then I started on the path, and I started talking to people in the field as I got older, as I started getting, as I started being, moving towards junior high and high school. And I said, "What do I need to do to be an engineer?" In theory, it seemed great, and I was good at math and science, but what do I need to do? And it said, "You need to be taking calculus by the time you're a senior, so that when you go to college, you've already seen calculus." And so that helped me figure out what courses I needed to take, to get myself ready to graduate high school with calculus, and having seen that in physics. And so started looking at universities, and I ended up at UC San Diego, and I met Carl because Carl was at San Diego State, networking, meeting people. And it was just a great experience. I matriculated through. Now, one thing that was really important for me was in high school, I had mentors at JPL. And so they continued to keep me engaged with JPL. And I really resonate with what Carl said about mentors. It's really important to have mentors. Actually, on the panel, Tony Vanilli is one of my mentors. You need to have mentors at all levels. You know, it's okay to have peer mentor because you're going to learn things from people that are in different spaces in their career and have different experiences. Like Tony teaches me about ACS, you know, my background is largely thermal. So, you know, you're learning things, you're learning how things operate. So, you know, my first internship at JPL was when I graduated from high school. So I was a high school graduate intern at JPL, and I interned for 7 consecutive summers. So I finished my master's, and then I turned full-time at JPL. Now, in my internship time period, I worked in a lot of different areas. I did, you know, I started just stocking cabinets, you know, with electronics, and that was great because I found out what a carbon resistor was. I found out what a Dale ohm resistor was and what it took to actually
So
solder.
you didn't feel that was beneath you to do that kind of work initially?
No, absolutely not, because you learn something in everything you do. And I draw on that even now because, you know, someone's like, oh, okay, we need to build a board for this box. I know what it means to build a board. I know that it takes a long time. I know that you have solder joints. I know there are things that can fail. And I learned that, you know, as a 17-year-old summer student. So as you matriculate through, you know, no job too small. There's no job that's too small that you can't learn something in the industry from. And so when I graduated with my master's degree, I started full-time at JPL, and I started as a thermal engineer. And then I absolutely love thermal engineering, but I really like the system side of thermal engineering. So then I started looking at other areas at JPL, because what's super cool about JPL is that where you start isn't where you end. And so there's so many opportunities and so many options. And then I learned about instrument systems engineering. And I thought, wow, I can do systems engineering of an overall instrument. This is really cool. And then I realized, I'm like, there are systems bigger than this. I can do a more broad area of systems engineering. And then I moved into systems engineering. And then within systems engineering, I really liked verification validation. And so I just kept rediscovering myself within my career and looking at different opportunities that were available. I moved into systems engineering largely because of Tony Vanilli and our conversations about systems engineering, and just helping me to understand how my interests fit within the overall sense of what we do at JPL, within the overall mission of JPL, which I just have a passion for, you know, and very fortunate to work at a company that I've always wanted to work for and do a lot of different things. And, you know, what I didn't realize is that getting a mechanical engineering degree, I mean, I was training for jobs I'd never heard of, and that didn't even exist when I was in college. Like we had in our instrument area, like when I was working instrument systems engineering, we had optical science engineers, optical mechanical engineers, things I'd never heard of, because you have optics that need to be very, very still in order to operate within an overall system to provide an image. And there's so many things that you can do that you may not even be considering. And that's what I've found in my career. And I continue to find that there's like all these different areas in the formulation side, all the way down to the launch operations side. So that's really how I got that together.
So help us out, particularly our viewers, for a minute. I'm gonna go around the table with this. If you're just explaining, so I'm interested in aerospace, but I really don't know much about JPL, Jet Propulsion Laboratory, its relationship with NASA, its relationship with Northrop Grumman, and that type of thing. Can you give some insight as to, or an overview of what JPL is, and you know how it relates to the other companies, organizations?
Certainly. Yes, so JPL is owned by Caltech. We're a federally funded research center, and we're under prime contract with NASA. And NASA Center, we're not per se a NASA center because we're owned by Caltech, we're not civil servants. However, all of the different areas of NASA, the centers and JPL, all have a charter. Like for instance, when you look at Kennedy, they deal with a lot of they deal primarily with launch type of activities. You look at Houston, they deal with manned flight. JPL is tasked with the robotic exploration of space. Now, what's really cool is that we have an opportunity to partner with different companies. Like we may go to Northrop Grumman to get a cryo cooler. We may go to Ball Aerospace to get a bus, or Orbital Sciences to get a bus. You know, we recognize there are a lot of people in the industry that do certain things really, really well. JPL likes to do one of a kind type things. And so in doing that, a lot of times we go to the experts in certain areas and say, hey, you know, we're working on this great, you know, new innovative instrument or a new method for coupling systems together, but we want to focus on that. So can you give us a cryo cooler, and can you give us a bus? And, you know, we'd like to have one more instrument. So let's go talk to JAXA, which is the Japanese Space Organization, or ISRA, the Indian Space Organization, and just try and partner with these people to put together an overall system. So we have international contacts, we have contacts within JPL, we build instruments in-house, we go out of house for instruments, we go out of house with all these different organizations to bring something together because we do one of a kind type things. We often leverage off the success of prior missions. Like for instance, when we look at the Curiosity rover, a lot of what we did on the Perseverance rover is leveraged off what we learn. It's not a carbon copy because there's no such thing as build to print. If I can say that twice, there's no such thing as build to print. It's always a little different. And so that's pretty much how we go about partnering.
That makes for a perfect segue to Tony. Tony, how about telling us a little bit about your background and explaining more because of what you've done with the different rovers, including the one that's currently on its way to Mars?
Yeah, sure. So interestingly, my background, I have a story that's very similar to Shantae's, as it turns out. I didn't know that. I also didn't know I created such a monster as system engineering as I did in you. So I'm sure I will pay for that later. When I was going to college, I got degrees in electrical and mechanical engineering, not in aerospace engineering. I wanted to do aerospace engineering, but my dad sat me down one day and said, son, you know, the aerospace industry, the bottom tends to drop out of it every 5 to 10 years. And so you're going to want to have something that you can, you know, have a job, put food on the table, eat, take care of yourself, family, so on. And so he kind of talked me into doing mechanical engineering. And I didn't listen. I got a degree in electrical engineering. And then I got a job at a standard electrical engineering company, National Instruments, and eventually found my way into graduate school, did mechanical engineering, and found my way over to JPL. And it's really important that you get a broad set of skills that are not overly specialized, because that's what allows you to do so many different things. And in the aerospace world, that is hugely important. It's one of the hallmarks of systems engineering to be able to appreciate and understand different challenges in different technical domains. And it turns out after you do it long enough, you begin to see the similarities. And so that's why it's easy to port your skills from one role to another. Work-wise, Vince, I forgot part of your question. I think you wanted me to get back to the rovers.
Yeah, well, tell us a little bit about what you do in terms of your aspect of systems engineering and specific to the rovers.
Right now, what I'm doing on Perseverance is I'm helping work with the, I call it the attitude control system, but it's a rover, so it doesn't really need attitude control. It doesn't fall out of the sky if you stop commanding it. It's not like a plane. It's more the navigation and pointing and attitude determination system. How does it know where it is? How does it navigate? How does it know what to point where? So we've got cameras that we've got to point at various places. We've got a high gain antenna that's gimbaled that we have to point. So I guess my role there is to provide, because I used to work on Spirit and Opportunity something like, 16, 17 years ago. It's been a long time. How do we come up with the operations procedures? How do we make sure that we stay on top of what the rover is doing? How do we get ahead of the rover? It's very much like how you drive a car. You know, you don't want to be looking just in front of your front bumper. You want to be looking a little bit further down the road. In our business, it's looking several days down the road, anticipating problems before they come up, and working with a team of people to identify them and solve them. And it takes all types. It takes all disciplines. So
yeah, I understand. We were talking earlier. All of us were talking. And actually, Carl, you brought the point up that the margin for error is pretty like non-existent when you're dealing with some of the things that you guys work with, because if the error happens, it may not be recoverable. Is that a correct way to put that, Carl?
Yeah, definitely. It's like, for example, if you're an engineer and you design a car and you drive the car halfway down the block and the wheel falls off, you can send a tow truck and go get the car, bring it back to the factory and improve on the design or
Wait a minute, we don't have rover tows out there to bring. No, we can't bring it
yeah,
back.
my AAA
No,
car
sir.
would not go pick up my satellite once it launched. Um, yeah, but when you're dealing with something that goes to space, most of the time, especially if you're going to Mars and places that are far away, once it's gone, it's gone. There were cases where, like, if you remember the Hubble telescope back when we were flying the space shuttle, the Hubble telescope wasn't far enough away to where you couldn't go to it, repair it, and get back. But a lot of things were going. I mean, Mars is pretty darn far. We've worked on satellites that are 4 times further than the moon. That once, telescopes that we send out there. Once those things are gone, they're gone. And so you really need to be very careful in your design that you design something that will not fail. And then you test and test and test and test and test to make sure it doesn't fail before you're finally ready to launch it. Um, and then even in those cases, there are times where you have to modify the software. But when it comes to the hardware and all of those systems, it's like when it's gone, and you can't fix it. So very little margin of error there.
Yeah, Tony, how long does it take for, it's probably either you or Shantae could answer that, maybe Carl, you could too. How long does it take for a rover from launch to landing on Mars?
It depends on the rover. I mean,
Oh, really?
you mean from the moment of
Yeah,
oh, you mean from launch to
from the
landing? I guess
moment
it
you
takes
launch
about
it to,
6 to 8 months. It depends on exactly where Earth and Mars are at the time you launch. We try to launch in a particular time frame that makes it as short as possible, but it's not always exactly the same. So 6 to 8 months from launch to landing.
oh, and that's interesting. So it depends on when you launch based on the relationship of
Yeah, as
Earth
Earth
and the
and Mars
orbit.
are going around the sun. Yep.
I just learned something. So, so I want to go back in this with all of you guys because we kind of know a little bit about your backgrounds and that type of thing, and any of you can chime in at any point about this. I'm trying to, in terms of the audience that is watching this program, and relate to the questions that I know that they have on their mind. Again, they're at the beginning, or they haven't even started their career; they're still in school. So could each of you kind of share your thoughts about that, your recommendations regarding that, to give them some insight, please?
Okay, I'll go ahead and start. So to me, I'm a firm believer in sort of math and science. And once you're able to sort of master, I think, math and science, in my view, you can go off and do anything, because everything is sort of based on math and science, if you ask me. And so even if you're going into music and things like that, it's, math and science is involved in all that. Whether you're going to be, a pilot, math and science. So to me, if you're even if you're going to go off and for law and things like that, it's the skills that you acquire once you can master math and science are applicable everywhere. So and I know a lot of times not everyone is like Shantae and I that knew, even Tony, that at a young age we had people to sort of guide us, or we knew what we wanted to go and do. I mean, there are times when I talk to high school seniors that have no idea um, what they want to do in life, and that's okay. Because even if you look at our careers, like, yeah, we knew we wanted to be engineers, but we never knew exactly what type of job we would end up having in engineering, and it changes based on the environment. So so to me, I think the best advice I could give is you should prepare yourself so that when the opportunity comes, you can sort of latch onto that train and take off with that opportunity. So if if you're not getting good grades in school, that's going to be a disadvantage. You got to study hard, get good grades, master whatever your craft is. So when the opportunity comes, you can grab on and take off with it.
I think that's really good, a really good point and advice that you're giving out. Unfortunately, I think that a lot of kids, not only do they not know what they want to do, but they also sometimes are discouraged by their peers because it's considered too nerdy to be really good at physics or calculus or whatever the case may be. Shante, you have talked to a lot of young people about the opportunities in aerospace, probably specific to JPL, et cetera. What do you tell them when you know that you have some smart kids out there that are interested, but may be holding back a bit?
You know, I tell them nerd and proud. You know, I tell them what my mom used to tell me, you know.
Is there a flag for that or something? No,
Yeah.
Sure.
You should make one.
You know, I used to get picked on a lot, well, for lots of reasons in elementary and junior high school and even in high school about, you know, you're such a nerd, you know, but they always wanted help with their homework. But it's one of those things where my mom said, you know, don't worry about it, you know, do what you're doing and just keep learning. And it really helped bolster my self-esteem to have someone encouraging me to continue to pursue math and science despite what others were saying. And she said, and you know, at the end of the day, you know, they may be working for you. They may be coming to you looking for a job because they didn't handle their business, you know, in school. And she just said, you just wait, you just wait. I mean, you know, that was no comfort, you know, in the immediate, but I just had my college reunion and my high school reunion, and it was very comforting then. But
I like your mom. I like her style.
Yeah.
No, but you bring up a very good point. And it is a sensitive thing with a lot of, you know, I've heard it. I have 3 daughters and I've heard it from all of them through high school and college. Their challenges of, you know, not really sometimes even being able to tell their quote unquote friends that they got a 98 on a test or something because they would be made fun of or they would be dissed or whatever. I'm not using the right terminology, but you know what I'm saying.
But those same friends 10 years from now are going to be coming to your daughters to borrow money. So it all comes out in the wash.
Yeah.
I like the way you think, Carl. I was just going to say, Tony, what's your take on what you recommend to young people that are facing those kind of challenges as they, you know, want to get into something like aerospace?
Well, first off, I'd start with what Carl said. Math and science are where you begin. That's the foundation. And from that, you can go to just about anything. In today's world, I would add 2 more skills that I would put on the list. I'd put software in there. And it doesn't mean that you have to be a whiz-bang programmer in legacy software, but you need to understand how you communicate with the machine and program it. Because unlike the 4 of us, when we're talking here, there's no context for a computer. There's no assumptions. There's no common frame of reference. You have to teach it everything, and that forces you to be rigorous and diligent. And that kind of gets into communication skills. How do you communicate with other people? How do you help them get over their assumptions that may not be correct about the way the world actually works? That's what the science and math are going to teach you, and you have to teach it to your other engineers. This is how you build a team. So I would recommend getting into team sports or doing something that forces you to be on a team working with other people, where you
That's
have
an
to
interesting perspective.
cope with the egos, right? Yeah, cope with the egos. That's where I was going to finish. And it really comes down to just egos and personalities.
So I'm going to see if you bring up something that's been brought up by some of the other professionals we've had on previous shows. And this is directed to you, Tony, and then I'll go around the room. But Tony, what do you look for when you're bringing new people into your fold in terms of your team and the teams that work in conjunction with you?
I guess the first thing I look for is curiosity. I'm looking for someone who will ask questions, who will challenge not just themselves, but also me. Challenge my assumptions and make sure that I have been rigorous and diligent and I've dotted all my I's and crossed all my T's. So that kind of curiosity and communication skills, right? How do they communicate? How do they fit in with other people? The technical background will show itself if it is there, and that's a necessary condition. If you don't have a certain minimum amount of technical knowledge, then I guess I can't. I will teach you a lot if you're on my team. I cannot teach you calculus and physics. You needed to have gotten that while you were in college, but I can teach you the specific skill sets that you will need for the job. So I wouldn't worry about that. What I'm looking for is curiosity and a willingness to learn.
I think those are great points. Shante, how about you?
Yes, actually, when I go through a lot of hiring, I'm looking to fill systems engineering positions. And first of all, systems engineers, I mean, now you're starting to see at different universities that there are systems engineering programs, but, systems engineers can be mechanical, electrical, computer science, math, physics. There are a lot of other disciplines that you study in school that find their way into systems engineering. When I'm looking at people that are more senior, I'm looking for what we call the T-type systems engineer, someone who's really deep in a discipline and they're wide in their breadth of understanding. But, I think it's really important to really deeply understand a discipline before you become a systems engineer. You need to have been in a place where you found yourself so deep in a hole that you've got nothing but first principles to dig yourself out with. And so when you learn that type of thinking, and you mature that thinking and you learn how to problem solve, it helps you in a broader sense. When I'm looking at people coming right out of school for systems engineering opportunities, I look for someone who understands first principles. Because at JPL, we build one of a kind things. We don't build a lot of the same satellite type. For instance, I think it's important that they do that. I love the NFL Sunday ticket. And without those satellites, I don't see my Steelers every week. I have to watch whatever's on television. So it is important that
Steelers, is that a football team?
Oh my gosh, yes.
Her football team.
Okay, I'm sorry, I didn't mean to throw you off. Go ahead.
We clearly need to have a conversation.
Exactly, right. Good thing we're not in the same room.
But it's important that people do that work. It's important to have GPS satellites because I have no sense of direction. These things are important. But at JPL, our charter is to build one of a kind type things. And when you're building one of a kind type things, you don't have like a manual that says this is how you do it. You have to understand the first principles. I'm looking to understand if you know how to apply V equals IR. I'm looking to understand if you know how to look at the conservation of mass, if you know how to look at QN equals Q out. If you just understand those things, I can teach you how to apply those in a broader sense over a different system. So I want to know if you can think. I want to know if you know how to problem solve. So I ask questions to try and drive those things out of the conversation.
Yeah, so all of you are coming around to saying the same thing. And part of that is that you guys are saying that if you are, the technical expertise is important, but it's not necessarily the most important. It's a base that has to be there to some degree. As Tony said, you have to know your calculus. I think Tony and Carl said that you have to know your calculus and your basics. But I hear all of you talking about personality and the psychology of thinking, creative thinking, being curious. Those seem to be things that are at the forefront when you're looking at somebody to come into to your companies. Would that be a good assessment?
Definitely, I think you've
I think
summed it
so.
up in a nutshell. It's definitely.
Yeah. So
because everybody's going to have, most of the resumes we see, most of the people we're going to interview, they're all going to have their technical skills pretty much down pat. So now it's a matter of finding out what differentiates them from the other person that we're interviewing. And because no one really designs any of these satellites and Mars rovers and such on their own, they're all team efforts. So if you get people that don't play well in teams, they may be the smartest person in the world, but they're not going to be any help to you. It's kind of, Tony, you kind of talked about the sports analogy a little bit. It's like as good as a basketball player as LeBron James is, and he's probably the best in the game right now, he's never inbounded the ball to himself. He needs 4 other guys on the court in order to make it happen, or he'll never win.
Oh, excuse me. I'm sorry. You said he was the best in the. Oh, okay. Sorry. Go ahead. You guys shouldn't use sports analogies around me.
And I'm not a LeBron fan, but the guy's good.
No, I'm just kidding. No, point taken though. I actually think the sports analogy and the team analogy of team sports is a very good one because you learn how to work with different personalities and things like that. And I can only imagine the size of the teams for any particular project at Jet Propulsion Laboratory, or for that matter at Northrop Grumman, and getting all those personalities to work kind of in sync to accomplish a goal.
One of
Yeah.
the other things that comes up out of the teams is the team analogy is when things go wrong, and they do go wrong. Nothing ever happens perfectly. And so when something goes wrong, if you think about a sports team having a bad game, how do they pick themselves up and recover? How do they carry on? They can only call so many timeouts. They can't, and when they're out of timeouts, they just got to play the game, and they got to suck it up and get to it. And it's the same thing in our world, as Carl mentioned, when you launch the bird, it's gone. When it's gone, it's gone. You can't bring it back and fix it. There's not a do-over. You have to play with what you have, with the people you brought to the party, to the team, with the gear they have on, until the game is done. And it's very much the same here in our business. Once we launch it, it's what we threw up in space. That's what we have to work with.
Sounds like there would be a lot of great satisfaction from success with that, though. When you put all that work and effort in, and you run into a couple of issues during the course of the launch of the program, and you're able to resolve it, and then able to accomplish the mission. That's got to be a great feeling.
Well, definitely.
It absolutely is.
Yeah, definitely.
Go ahead, Carl.
I think one thing, and we've all probably shared on this, is usually, once you've worked on a vehicle and such, and when that thing actually launches, you'll find yourself in a conference room watching a simulcast of a launch, or you may be even lucky enough to be at the launch site. But once that thing sort of gets up in the air and takes off, you get this sigh of relief in your heart. That's like, hey, it's gone. It didn't come back down. And when you think about it, you're working some of these programs, you're working 5, 6, sometimes 10 years on something, and to work that long on something and not have it be successful, it's a lot. And it can be, and we've had a couple that didn't go the way they were supposed to, and it can be traumatic at times.
I bet. Carl, while we're talking, you earlier at the beginning of the program, I joked about your paragraph long title, but can you tell us what aspect of what you do with satellites and test beds and what that's all about, please?
Yeah, so for those of you who don't know what a test bed is, it's pretty much when you build a satellite, you have to prove out your design on what's called a prototype, right? And so a test bed is really prototypes of different electronic systems that go on the satellite that you put together as engineering models and such, that you actually test. So if you imagine you're building a car or something over here, you're going to have, you guys have been to the auto show before. We kind of see the one that they kind of show off, and and that they use that to test out various technologies and such. It's really kind of a test bed for testing out various technology, testing out various systems, running the software and make sure that it works. So what I do is I actually manage a team of multidiscipline engineers. Some are computer science majors. I have mechanical engineers. I have electrical engineers that actually work on the different systems, assemble them together, test them out, and make sure that it works, so that when they actually build the final version of the satellite that's going to launch, we know that with a reasonable amount of success, that we're going to have a system that's going to be viable and that's going to fulfill the mission. And so I ended up, after many years, starting out as one of the, the people in the vertical part of the T that Shantae talks about. I had my area of expertise, and then I branched out and then became a manager. And the interesting part of that is a lot of the people that I manage, I can't do all of their jobs. That's why I need a team. So being able to have the breadth to understand that if my software guy has a problem and comes to me, who wasn't a computer science major, I understand enough about software to where I can sit with them and read their code. I understand enough about mechanical engineering that if two things do not fit together correctly, I can sort of give guidance to the mechanical engineers and such.
One of the common denominators, and I think one of the biggest takeaways of the conversation we've had during this hour, all three of you have talked about keeping your options open, and even more importantly, when you're looking at what you're majoring in and what you're thinking you want to do as a career, that you think in a broader sense and not necessarily be, and we touched on this in the pre-show, not necessarily be so laser focused that you miss an opportunity that may be just a couple of degrees to the left or right. Talking in you guys' language, huh? No, but that's the pilot coming out of me too. But I that that really rings true because a lot of the guests that we young aviation or aspiring young aviation professional guests that we've had on this program over the last couple of months, and the common denominator with them is that they've been on a track, as I mentioned before. They've been on this pilot track to be a professional pilot or something similar to that in aviation, and they've come to almost a screeching halt because things have changed as a result of COVID-19, et cetera. And now they're regrouping. Some of them are going on to get a graduate degree, a master's, in business or a master's in aerospace technology or science or engineering and things of that nature. I just wanted to make sure that we covered and make sure you guys have said what you'd like to say about that process of what now that you're or as you're finishing up school, and now that you've kind of run into a situation where you may have to shift gears and go into a different area, that because I guess the point I'm trying to make is the same thing all three of you have said. Just because you don't have a degree in aerospace engineering doesn't mean that you couldn't work for a JPL or Northrop Grumman. Carl, you just mentioned like 3 or 4 or 5 different disciplines. In fact, all of you have that all relate to the type of projects that you guys work on. Anybody want to expand on that a little bit?
Yeah, I think definitely.
I think
Don't get discouraged if the thing you want to do, if there are no opportunities available. Sometimes maybe if you're a pilot, for example, if you're training to be a pilot, maybe you maintain that as sort of a hobby that you keep sort of working on the side while you go off and work on something else like your science degree or mathematics or such, to stay connected to that, because you never know when the opportunities are going to shift back. Like Tony said, where his dad came to him and said, "Hey, the bottom drops out of aerospace, every 5 years or so." But the thing is,
10 years.
10 years. You've got to see that kind of come in. But if you sort of keep your options open, there are many ways to get to the destination you're trying to get to. Like, for example, we're here in California, but if you're going from California to New York, there isn't just one way to get there. There are many ways to get there. And sometimes, you may be heading down a road and that freeway may be closed, but you'll kind of, find another way to get there. So definitely don't lose hope. Don't be discouraged, because there are many paths to get to your final destination.
Tony, you were going to say something.
Well, Carl actually took what I was going to say, but I'm going to pile on with it. I'm
Sorry,
going to
Tony.
get creative.
He took some of my stuff too, but that's okay. He does that.
He covered it well. Get creative. Don't give up. You have the set of skills that you have, and one thing that I'm reminded of, we talk about pilots a lot. A good pilot is obligated to always learn from his environment, always learn from what's going on around him or her. And that is what we want in our engineers too. We want people who are always learning. That's why I said curiosity earlier. When you keep your eyes open like that, when you're paying attention, that enables you to be creative and to see opportunities that you might not realize if you stay too narrowly focused on, I'm just going to do this one thing. There are many ways to get there. I mean, I started out as a double E, then I went into mechanical engineering. Now I do aerospace, and most of the work I do is in software at the present time. So that's my road, and I wouldn't call myself a computer scientist, but I can hang with them if I need to. And it's because I picked up those skills along the way. So,
Point taken. Yeah. Shantae?
Yeah, I certainly echo what these gentlemen mentioned here. And, and Carl mentioned earlier about networking. There are a lot of networking tools out there, like, for instance, LinkedIn, getting out there and networking and learning about different opportunities. Even if you're, you start looking at different job opportunities that exist now, because jobs that you never imagined when you were getting your degree, when you were getting your pilot license, are actually out there, and you're finding that you have the skills that are applicable to these new areas. There are some people that never saw themselves building an app, but if you have this background in math and science, you can pick up, the necessary coding skills to build an app. Right now, there are needs for different apps out there related to our current pandemic. when you look at contact tracing and you look at all the different things that people are trying to manage in this pandemic, a lot of people are leaning on apps and other tools. And if you have the skill set to do that type of work, then there may be opportunities for you. And so as you're looking at LinkedIn and you're looking at comments that people are making that may be in a similar situation, you may be able to derive from that other places you can get engaged. So the whole important thing is to, you know, really stay engaged in what your area of interest is and find ways to leverage what you know to find your way within our current situation. I mean, you know, as you heard from all of us, you know, we didn't necessarily land exactly where we sought out because we had breadth in our respective areas. And we looked within our companies to find places that would be a good fit for our capability set. And so I really encourage people to do that type of thing within the broader sense of where we are right now.
I have a quick curiosity question for any of you guys, and that is, today's kids are a lot more technically savvy than any of us were to some degree because of the technology that's in their face from practically when they're born. Has that played a role or affected, you know, the type of the young people that are coming up into your industry?
Yes, I think definitely. When you look at the people that have been in the industry for a while and you look at the folks that come out, you find that the people that are coming out of school are less intimidated by technology. You know, I remember when we first got email. That's how old I am. When we first got email, we had some of these folks that were like 40 years into their career and they're like, what do you mean I can't just write this memo? And we had people that were writing things out longhand and then giving them to, you know, the administrative assistants to actually type up because they're like, I don't want any part of that. But when you have these young folks that have been immersed in this since the very beginning, they have less hesitance to using the tools and pushing the tools even further. Like we have summer students that come in and there's certain things where I just don't have time to come up the learning curve on some of these tools because I just have too much stuff to do. And to be able to give it to an intern who's never seen the tool, but has that background, has that savvy, and just, you know, has this desire to just go after. I've saved so much time. I've saved myself so much time on weekends, you know, because I'm able to just give an intern who is not at all intimidated by the task. So I think that's probably one of the biggest things that I've seen with regards to folks coming out, having had that exposure to technology so early.
Yeah,
Oh,
Shante,
Tony?
Shante, I find with kind of piggybacking, I find that, you know, with the interns that are new hires, right? There's some new technology out there, so that you can tell them, hey, go learn this. And spend a week or a month or whatever learning that, and then come back and teach it to me in 5 minutes, right? It's because you don't really have, you know, especially as you kind of go up and get up in management, you don't have the time to learn all of this stuff. But these younger kids, they're energetic, they're fresh, they're looking for that. And like you said, they don't fear the technology. It's interesting because they're still, you know, Northrop's one of those companies where people are still retiring with pensions, which are kind of hard to find these days. But there's still guys working there that the day they started, you know, every engineer didn't have a computer on their desk, didn't have a laptop, didn't have a cell phone. And, you know, I remember stories about those guys that would give, you know, paper to their admin and secretaries and say, hey, type this up, because they didn't like to or didn't know how to use a computer. And it's funny because it's just getting exponentially worse when it comes to technology. Like nowadays, there are kids coming out of school that are able to use things that we don't know how to do. And it's just, but it's great because it just tells you that it's boundless. You know, as the kind of the curve goes up, you know, I mean, we're completely unlimited in where we can go and what we can do.
Yeah, Tony, did you have anything you wanted to add to that before we start to wrap things up?
Yeah, let me quickly throw on a few things. So one of the things, and this kind of goes back to the stuff that we kind of look for, right? People are very technologically facile now, right? They have these experiences. We are looking at people that when we do interviews, when we do recruitment, we discover students coming out of school who have already built a CubeSat or who've even already flown it, perhaps, right? And that just never happened 20 years ago. That was a pipe dream, right? So there's a set of experiences there that you know, when you're looking for things to make yourself more attractive to prospective employers, you want to show those kinds of experiences, right? I made this, I was part of a team that built X, we flew Y. And the other thing I would say to make sure that you're aware of, because we take so much of this new high technology for granted, is make sure that you understand how it really works under the hood. Because those of us old timers will ask you a few questions like, do you know how it breaks? Right? We want to know if you've been curious enough to figure out how it fails and how you work around that failure. Because as we said earlier, all of us, when you launch it, it's gone. And there ain't a mission yet that has gone completely flawlessly. There's always been something that has to happen along the way that you have to fix in flight with what you have on hand.
So I wanted to thank all of you guys for all of this insight. But before we close, do any of you want to share, and you can just do it briefly because I got about a minute apiece for you, one of your greatest experiences in the industry, a project you worked on or anything like that you'd like to share that was, you know, a memorable, exciting experience for you?
Wow. For me, it's about the people you get to meet. You know, because of being involved in this industry, I've actually gotten to meet, you know, Mae Jemison, who was the first female astronaut, African-American in space. You know, I've got to meet Bill Clinton. You know, things. And so to me, that's, you know, really interesting sort of, you know, you never know who you're going to meet, who you're going to come across. And the fact that this, you know, field has gotten me the opportunity to do that has been pretty amazing.
Great. Shantae or Tony?
Well, I will say I was in a situation in which we were testing a spacecraft and something just went completely awry. And, you know, having that, you know, kind of like an Apollo 13 moment when you don't really, like, I was new to the program. I didn't understand much about the spacecraft, but I did understand thermal engineering. And so we were having a problem that was really thermal related, and I was off site. I was somewhere in DC helping out with the spacecraft and having to convince people that didn't know me that they needed my help. I'm like, you know, we're going to burn up the battery if you don't listen to me. And so let's figure this out. And to be able to work with those folks and actually draw on my experience to keep the spacecraft from failing completely in the chamber. And so it was a reaffirming moment, because sometimes you get these gremlins in your head and you're like, can I really do this job? Do I really know what I'm doing? And then that moment comes and you don't have time to doubt yourself. You just have to get in there and you have to count on your skill set to actually solve the problem. And I was able to help the team get through that. And so, you know, I draw on that experience from time to time when I just find myself at a point where I'm like, I have no idea what to do with this problem. So I would say that was probably my moment.
All right, Tony, we have about a minute.
I think I can wrap it up in a minute. I guess my experience that I go back to the most is the first launch that I worked. And what was exciting about that was it was a hairy ride on launch. We had some anomalies and the spacecraft didn't call in on time. And so we were worried if we had just launched a brick or a spacecraft. It turned out it was a spacecraft. Everything was okay. But during that long 15 or so minutes when we didn't have signal and we're wondering where our bright, shiny new spacecraft was, I looked around the room and I realized it was the people that made the difference. And that kind of brought me back to something one of my college advisors told me, was that always be seeking to work with good people, because that brings it all home, right? When things go wrong, you have good people to work together to work through it, or to commiserate with on the bad days, and there are bad days. But when things go right, these are your friends and your family that you work with through thick and thin. So it's always about the people and the teams that you work with, in addition to the high technology. You have it all.
You guys have brought some great information and insight to the aerospace industry. I hope that it's been helpful for those who have been watching, and really appreciate having all of you on to talk about your experiences and the opportunities and options that a lot of our aspiring young professionals have in terms of considering aerospace as a field. So I want to thank all of you for being on the program today, being on the panel, and sharing some of that wisdom and experience that you've had. On behalf of the Bob Hoover Legacy Foundation, our president, Tracy Forrest, chairman, Michael Herman, thank you again, everyone, for watching. I'm Vince Mickens, so stay safe, stay healthy, fly safe, and until next Thursday, blue skies. Thanks, everybody.
Even